You people were supposed to have acquired some knowledge and some brain power in these last years. What are you people talking about?
All of Cyrus's brain power has been given to the Lodge and will be used against us during the New World Order.
What is the
Yeah.
Right,
I mean,
he's
that's what all we know is
Lodge Light. He's
what's
Lodge
The
Light.
way
LITE. He ain't paying the full.
in his
stick.
case,
yeah.
the weight
Torque,
of the
rotational force.
suspended object, unless he's got a car parked on a bridge or some shit. I'll just go with the mass of the system plus whatever's loaded on
We
it.
got torque
It-
applied torque, right?
You can't
And
apply
resulting-
torque. What's wrong with you? In
We can
physics
apply
and
torque.
mechanics, torque is
Is-
the rotational correspondent of linear force.
Torque is
You know what
rotational
correspondent
force.
means?
So you apply force.
Bending moment.
And
It's
the
called bending
resultant
moment.
Is torque.
effect.
Or
And then
Torque is
torsion
result.
or bending
Torque
moment.
is result. Torque is not applied. Torque isn't
Correct.
a thing to apply. What? It's like you misunderstand basic mechanics and basic English at the same time. It's
All
ridiculous.
right, can we get back to
English
the?
at all.
Can we get
I'm
back to the?
still
Hold
learning.
on, guys. Yo, I want to get back to the L bar because there's been some guy asking for like 15 minutes now to get back to the L bar. Can we get back to that?
Wait, he wants
Okay.
to lose live on air.
Finished.
Go for it.
L bar. There's a torque holding
reason-
up the end of the L bar. Wait a minute.
Upside down L bar.
Quiet. So if I'm an engineer, I can look at the stress lines on the torque. So how can I do that?
Exactly.
Or you're just looking at something.
So there is something being emitted from the stress line.
I got you.
It's
All right, let's do a
UV
free body
light or it's-
diagram.
Wait, I mean, just be quiet.
Very easy.
Or it's
I'm replying to
infrared
you.
light.
Is this a
Yeah,
system
so
in motion
there
or a
is
static?
energy
Cyrus is
being
trying to use a free body
displayed.
diagram to engineer the New World Order for the Masons.
Oh god.
Yo, can we let this guy finish, please? You guys are like spazzing out. Somebody's hot micing, crinkling papers or something.
Cole, shut your mic.
Oh,
Cole's hot mic.
So you've got the gravity on for creating the torque. The torque is being converted into another energy. You can't measure it.
Right.
It's
One of the
there
busiest-
all the time.
Do you want to show me the flow diagram for what you just said?
Should be simple enough to visually imagine. Or, yeah. It's not very complicated. That's what I've been saying this whole time.
Blow diagram.
I wasn't talking to you, Fundy. I'm asking the guy a question.
Yeah, I'm going to answer
You
anyways.
got
If you can't
force.
imagine this, then you lack imagination.
You just talk all the time, shush. The guy's still here.
You might have scared him off.
You know what? In order to speak about the L shape, that would be statics, which is what? So it's like second year course or first year. There's prerequisites. You got to take physics 1 and 2, and it's basic algebra. Some calculus, but you do not need to differentiate. Fuck that shit. Just algebra and some basic physics, Newtonian mechanics.
It's not very.
So
It's not very
shit doesn't get
complicated.
confused for you.
It's
You're
getting-
confused,
It's
buddy.
getting pulled down and it's resisting it. Where is its strength coming from? What fuel supply is being exhausted to retain its shape?
Fundy, are you aware that
The
there is a
environment,
distinction
Fundy.
between passive structural resistance and applied resistance? Do you acknowledge the distinction, yes or no?
Well, which one is a solid lump of iron
You
applying?
can't even answer a yes or no question. What's wrong with you, dude?
Yeah,
I'm not
yeah,
trying
I
to trap-
acknowledge
I'm
them.
not trying to trap you. I'm not trying to call you a fag.
I acknowledge the difference. I acknowledge the difference. Now, which one is the
Okay,
L-shaped
then it's
upside down
over.
L bar of iron applying?
It's over. If you acknowledge the difference, then it's over. You're describing a static system. This is not active resistance. So therefore,
you're not
it's
gonna
not.
answer the
It's
question.
a non-starter. It's a
Which-
non-starter. You're wasting your time.
Which one and what fuel supply is being exhausted to keep its shape, resisting
It's
the
a
tug of gravity?
static system. Did you not hear what I said? You just acknowledged it without realizing what you
So
acknowledged.
you have no answer?
That is retarded.
You can just answer for all of us, please.
He already answered it.
What's the answer then?
It's structural resistance. It's when you are talking about comparing
Okay, resistance. Resistance.
listen,
Where is
you
it
have
getting its fuel? What is the fuel supply that is being exhausted in order to resist?
Listen,
I got
didn't-
you. It's the electron bond.
So
Yeah.
I didn't-
What bonds the electrons together?
It's like when you're talking about a
Okay,
cup of
it's
glass.
the electron bonds. Well, if I make it out of iron 56, the most stable, in fact, deemed a perfectly stable type of material, then what are you exhausting then? When you have a no half-life, permanently stable element that I make this shape out of?
Yeah, but the
being
electron, right,
exhausted?
is spinning around the nucleus all the time. There's energy from the environment. Only when we reach absolute zero, we don't fucking know, and you can say all this collapses. Cool. But since we have thermal energy in the environment, we just found it this way. All right, let's move on. Due to
If it's at
that, we have
if
actually
it's at
shit going
absolute
on
zero,
inside.
it'll last even longer. That wouldn't make
Hey,
it
look,
collapse.
if you
That
don't
would make it even
believe it,
more rigid.
look, I got you. If you don't believe it, you can take your bar of iron and put some
If it were
thermal
at
energy,
absolute zero,
and
it
it's
would
not going to
last
do any
even
work.
longer.
Hold on, it's not going to do any work. Just put it on the table, heat it up, keep
No, it
inputting
is doing
energy.
work. It's
Then it will
resisting
start
gravity.
glowing at you. No, you're raising its temperature. There's more intermolecular activity, but there's no work. The overall system, the bar of iron, did not get displaced in space. You can say that,
So,
let's say the molecular jittering is displacing. Yeah, you went intermolecular. Okay, we're not studying an
so
intermolecular system. We're
simple
studying
question:
the macro, right? Not the micro.
what fuel supply will eventually be exhausted as it continues to do this work perpetually?
From the
Why are
sun.
you
I got you from the
assuming that
sun.
there's a
The
fuel
heat
supply? What are you
energy,
talking about?
the thermal input is coming in from the sun, aka the environment. And until the sun dies, we're good. And you can say who created the sun?
This
It's
lump
God.
of
We're good.
iron,
Handshake.
this
Let's move on.
this lump of iron to retain its shape does not require the sun to exist.
Yeah, this is why they allowed teachers to cane their students. Belligerent confusion.
Yeah,
It's just
not an
pain in
answer,
the ass.
and also a debunk of the last guy's statement.
Yeah,
The
people
sun
You're
does
people
not.
not have
You're
to
not
exist
willing. You're
for
not
a piece of
willing to
iron
be
to retain
taught.
its shape.
You're not willing to be taught. You're not willing to learn. You just want to
Well,
talk. It's a waste of
you're not
time.
capable of teaching, obviously, so let someone else try.
I
Oh,
tried.
All
I
right.
just tried.
If
I
I'm not
just
capable of teaching, what is it that I'm not capable of teaching? Go ahead.
I just
Teach
tried. I
us.
just said two sentences and you just jumped over me and you started talking. You finally muted me. And now you didn't even ask me to finish what I was talking about because you were not interested to have an answer.
that's right.
So, like the
Who, me?
example of a cup of glass and a Prince Rupert drop. You didn't add any energy to the Prince Rupert drop. It's just the structural configuration of that glass when it was
Geometry.
cooled like that. It's the geometry, the structure of it. You didn't add any energy to make that Prince Rupert drop resist a powerful hydraulic press.
Okay.
So you didn't add any energy. You didn't need to use any energy, any amount of supplement of energy to resist that that press.
Okay.
Compared,
You know that Prince Rupert drops are under an incredible amount of stress, right?
No, it's not
But they're not
stress. It's
moving.
the
Yeah,
people.
yeah.
No,
Wait.
it's not
What kind of
stress. It's
Hold
stress?
the
on.
people. They try to
Hold
Oh,
on.
implement
yes, yes.
I don't
There's
know what the
intermolecular
silence is
tension.
for. I don't know what
Thank
the
you.
silence
Who
is for.
said it?
I asked him a single
High
little
five.
question.
Yeah. What kind
You
of stress?
understand that the Prince Rupert drop is under an
They're
incredible
not.
amount
It's
of
not
tension.
moving though.
What kind of
Define it.
stress? I mean, somebody just said it for you, but what kind of stress?
I don't know. I'd say something
Arm wrestling
involving
stress.
molecular arrangement and bonds of that
Okay,
matter.
there you go. So the internal stresses, right?
Yes,
I'm a
Extreme
step.
tension, thus it
that
can
has been
withstand a lot of compression from the outside.
that is at the
I see.
core of my original question. Now, does the strength of those bonds give up? And that is why I was mentioning half-lives. But then I specifically addressed that
Yes,
situation with iron 56 considered to be the perfectly stable form of matter that does not
you don't
have a
have to
half-life.
you don't have to go to half-life to deform the structure. There's plastic and elastic deformation. Elastic is when you stretch the bar of iron and when you let it go, it returns back to its original dimension. Plastic deformation will cause necking in a bar of iron, right? When it's stretched and when you let it go, it's a dash longer than the original. Now
Yeah, but
you actually displaced the molecular shearing between the fucking like layers, right? So
guess
there's
what,
Well,
movement
Cyrus?
actually. That's why it neck.
Cyrus, you might be the first person to saying something actually addressing the root of all of this. So you're saying that there's deformation that occurs on what level?
Molecular crystalline structures. I studied this with properties of materials. The crystalline
Yeah.
structure,
Look,
right,
let's
and the
keep it clean
property
here.
of that crystal.
Just between the
Only
two of us, man.
superficial
Other
of
people
the
are gonna
material.
chime in and say retarded shit.
Okay.
You're the first person to say something intelligible on this matter, actually addressing the point. So I want to listen to you on this. So this iron 56 L bar, you're saying it actually will collapse, just to use that term, but it's not because of half-life. It's because of, you said, what sort of deformation?
Okay, when I apply a force on it, if it deforms, right, its shape changes, and when I let go of the force, it returns back to its original shape. That's elastic.
Okay.
Plastic is when you like when you actually like stretch the bar of iron and you let it go, and it's a little bit longer, and it will neck. There's a spot that got thinner if you're applying tension. So if it doesn't go back to its
so
original length,
plastic,
it plastically
correct.
deformed, which means the inner molecular. So when iron solidified, when iron was hot, When everything did the handshake, your arm wrestling, the intermolecular arm wrestling, now they're solidified. And actually, based on the crystalline structure that you solidify it at, it has different strength for the same exact chemical
Sure.
composition. Right? We can
Sure,
get into
sure,
austenite,
sure.
martenite, blah blah blah. If you like steel and iron.
Well, not
So
necessary.
this handshake, you can break it, you can yield it. There's a little bit of give in
Okay.
between this
Okay.
intermolecular handshake. Okay.
Well,
Once you
I'm
go
not expecting
beyond
you
Let me
the
to.
try one
give,
more thing.
okay, shoot.
We're
Hold
trying.
on, let me try one more thing.
All right.
What's up? You're right. Let's finish it up. You've been going a lot of people want to get in, so
All right.
go ahead with your thing. No, finish this up and let's get
All
some
right.
other people in here.
All I want to know, Syrus, is what is losing strength when that upside down L-shaped iron 56 L bar is plastically deforming? What is it that is like
Oh,
losing strength and giving up?
that would be the shear plane. So depends on your stress type. And if you want to study torsion, then like let's say whatever
Give
your
her a simple
material is,
answer.
you can look it up. They're the tensile strength. They can no longer hold on to each other and they move from each other. If you're applying
That's
torsion,
not
they will slip past each other.
that's not an answer. There's
What do
a
you mean?
single lump of iron in a certain shape. It's plastically deforming. Cool term you taught me, man. I give you credit there. Kudos, man. I didn't know
Yeah.
that okay, so plastic deformation is occurring, but what exactly is loosening its
Spaghettification.
grip on the other thing?
The iron molecules between. If it's just solid iron, it's not an alloy. Yeah, iron between irons
I
no
know
longer hold its
I
grip.
know it's made out of iron. I know it's made out of iron. Saying iron is losing its grip on iron isn't good enough.
Correct.
The
What is
molecular
Molecular
bonds.
It is.
He's talking about the molecular bonds.
Not just that, but the structure.
that also
molecular,
doesn't mean anything yet.
You have the molecular
Funny. All
bond.
right, funny. Just hold on, man. A lot
Yeah,
of people want to get in. I got on. Just take
I'll
5 real
take a
quick.
break. Yeah, all good, man. All good.
Just 5. Just take 5 real quick. Thank you.
5 days, please.
Can I answer the question?
All right, go ahead.
It's the structure of
And
the
I add something to that. If you would apply enough pressure to the iron bar, what's going to happen at the fulcrum? And the iron bar bends. It
will
heats
deform,
up, doesn't it?
So to answer
It'll
his
deform.
question,
So it heats up to deform.
It will deform.
Applying the pressure
Nah.
into the iron bar,
Ooh.
then at the fulcrum, it will heat up.
so
And
to
it
answer
will
After
bend
the
because of
deformation,
the energy
not
put into
pre-deformation.
it.
what you said,
You didn't heat it up.
When
Okay.
when the iron bar is sitting there defying gravity, right? It's actually producing energy, but you can't measure it.
All right.
And what energy it's
Necros is trying to get
transferring
in.
into.
Yeah,
It could be anything.
because
It could be heat,
because of the weight of the extension.
ultraviolet light. It could be anything. You can't.
Hold on, guys. Yo.
Wait a minute. Let me finish. It could be any sort of energy, but you can't measure it because you can't isolate the whole system. So to sit back and say
all
that
right, that was
gravity,
good. So
this is just
Necros
my
was trying
little
to.
thing
Oh,
I
you're
just
still
thought of
going?
now, right? If
Yeah,
gravity
he
was mass
monologue.
attracting mass,
My
right?
God.
But he was
No one
mass
here.
attracting mass, then the iron bar would producing the mass into energy, which it shouldn't be able to do. But if it was,
No
say,
one cares.
electrostatics and the electrostatics was pulling the bar down, it would be producing energy and putting it into another form. Just think about that.
Oh, I thought about it. I got another
So-
thing I'm going to body Syrus with after, but let's let Necros go. I mean, I don't know if you can hear his mic or not. He was a little low. Go ahead, Necros.
So I wanted just to answer Fundy's question. So what made the bar collapse at that moment is just the structural integrity of its molecule. So how their molecule and their geometry, there is that bounding between the molecules in all the solids. The bounding is always there. But what makes the structure collapse is how that structure of molecules is shaped or engineered like hexagon. You have it in a quartz crystal.
The lattice is what you're looking to say, the crystalline lattice.
Yeah, the crystalline lattice. Like you have a hexagon. That's what makes the quartz crystals and the different types of crystals that solid and that resistant because of the structure of their molecule, how they are shaped or geometrically placed inside the structure to form the structure of that solid shape, of solid thing that you have. So if you change that metal bar with something, some molecules that have the same properties, but their structure is different. Like you have, instead of having a cube, you have a pyramid. You have a pyramid that is pointing up, and one next to it, another pyramid is pointing down. It will form, put another one, and it will form a solid that will have better structure.
Guys, a bomb just went off near me. Sorry, I don't mean to interrupt, but like a literal bomb just went off. I'm looking into it.
All right, let us know. Okay, go ahead, Necros.
Okay, yeah,
Wrap this
yeah.
up, Necros, please.
He's in Iran.
Yeah, I finished. It's just that structure of those molecules. Like it's like when you are building a bridge, you are trying to do exactly the same thing. You're trying to make the structures of those bars hold the bridge or the tower that you are making. So that structure that you are making will make the shape or the building or the bridge more solid. That's like
Okay.
Solid.
All right. Did anyone else want to get in? I got one last thing I'm going to try to body Syrus with. If not,
Go for it. It's gonna be funny.
It's not going to happen. Well, it's 2-0 already.
it's about
so.
to happen. It's about to happen.
Oh,
No, it's going to happen right now.
Shoot.
Okay. If I can make heat, do we have energy if I made heat?
Yeah, thermal energy, absolutely. Yeah, of course. And you probably have it from chemical energy stored. Yeah,
okay, we have
heat.
Hold on,
how'd you
guys.
define heat? What's heat? Because heat
games.
is a vector. No, it's not working. No physics. No, I got you. Heat is a vector. Temperature is scalar. So we need to know this in thermodynamics. Heat transfers and it requires a gradient. Temperature is the driver of heat transfer. Okay, so that's what I'm saying. There is actually a difference.
If I make something hot, do I have energy?
So you increased its temperature. Yeah, you have input energy into that. Yes, yeah, you put energy in. Yes.
Okay.
Absolutely, you spent energy in.
Okay, if I have a hydraulic press pressing down on a Prince Rupert's drop, does that create heat or a temperature increase?
I don't think so.
Only if there's motion. No, only if there's friction, like something moves. You should not create heat unless there's
pressing. So if I just have a hydraulic press just pressing down on a Prince Rupert's drop, you're telling me there's no heat?
Yeah, the heat would happen when you have compression. Yeah, if there's no compression, even down at the molecular level, there has to be movement. That movement is what's generating the heat. There has to be compression. Right. If there's no compression, which means there's no displacement, then there's no heat and no work was done.
And in this example, the only thing likely to compress is the plate of the hydraulic press, if it's too soft.
Well, if the plate doesn't compress, it's not going to heat up. But like while it's compressing, while it's deforming, oh yeah, it's heating up. Then you'll actually put your hand there and feel the temperature difference. Yeah, totally.
But if it's got sufficient hardness,
is that it, Jeremy? Did you body bag yourself again? I'm sorry, Elijah. I think he just body bagged himself.
Yeah, it's all right.
Yeah, if there's no, I don't do that a lot, bro. Get the fuck out of here. If there's no heat being made when you're pressing down on something, then I guess I'll have to go back to the Wile E. Coyote blueprint drawing board.
Yeah, it depends on the structures that you are using it. So if it is a Prince Rupert drop against the press, the metal of the press, yeah, there will be heat because there will be movement in the molecular structure of that metal. Because the Prince Rupert drop is.
I mean, isn't that the reason why we have the molten core?
If you change the head of that press with the diamond and you push it against the diamond, no, there will be no heat until it collapsed, till that energy change into that structure collapsing, and that diamond will just shred apart. There is no movement. Yeah, the diamonds will not heat because of their structure. The structure will not permit that movement. You can't move it until it collapsed and cracked.
You know what's so cool about this? Is for the same exact material, it is the crystalline structure. Like when it crystallizes, how it crystallizes. Body-centered versus face-centered and all that. Very cool stuff, man. You know, and that will actually determine what how strong the material is.
This is what heat tempering and all that's about. Like how they make swords, or how they make like tool steels. There's one that's interesting to me. I'll just do it quickly. Like chisels, like if you're doing metal carving, what do they call it? Engraving. You go through a color process, and you have to, if you want it to have a certain profile, you stop when the color has reached a certain point, and then you have a physical profile now, and you can determine that based on the color of the metal when you heat it up.
Yo, I just AI'd it. It said that. I thought you were done, bro. Maybe I'm lagging out. Go ahead, hurry up.
No, that's just my normal pauses. Go ahead.
I know, that's why it's a shit show. With the guys that do that, I do that once in a while too, and it causes a shit show. I know. Yo, I just Googled it. It said you can have no macroscopic movement with pressing and heat is created.
Suspicious.
Answer, is that like a university citation or what is this? Go ahead.
That's
Follow the link.
AI
I want to read it. So they have micro movements, and then again back to, I think, who was it, Jake? I think it was it Jake that said it. Yeah, you got to have at least like micro movements, which are still displacement, and due to that shear action, friction, it'll heat up the material.
Yeah,
otherwise, I don't know where the heat is coming from.
You got to be moving.
Are you familiar with the term? Are you familiar with the term atomic compression? No, my bad.
So something got compressed.
Atomic friction. Atomic friction.
No, this is where, again, out of my wheelhouse, mechanical engineering.
I got 2 wins. The nuclear one and this one. That's 2 wins.
You ain't no nuclear physicist. Get out of here, buddy. Well,
it don't matter.
Get into it. What about atomic friction? Teach me.
I'll give I'm
willing to learn. Fine, draw, but teach me. I want to know. Go ahead, keep reading. What about this atomic friction? Does it move or no motion, or what's it say?
If it has any validity, it would be down to its geometry, right?
I'm just saying, bro, the AI machine is saying that you can have this heat made with no movement. I don't know. You got
it might be hallucinating an answer. There's going to have to be some kind of movement to generate heat. There has to be energy imparted onto something by displacing it.
What they probably mean is no perceivable movement. But that's just being inaccurate.
Like what you're talking about there with your atomic friction is like when you're starting, when you're trying to start a fire by rubbing 2 sticks together, right? You're heating up the lattice by rubbing the two atomic structures against each other. And that's exciting the molecules, exciting the atoms.
Hey, you said lattice, the crystalline lattice. You know what you're talking about. Nice.
Yeah, for 70 IQ, I do okay sometimes.
70 IQ? Is that what you got?
70 IQ,
that's terrible.
Yeah, that's what you've got. Some of these other people must not even have single digits. Like sub-single digit. Some of the conversations.
I don't believe you.
How about
bullshit?
This,
How'd you get 70 IQ?
Cyrus, he's trolling us. He's trolling us. Cyrus, here
maybe,
we go.
Maybe it's logarithmic.
You got a Peltier plate. Right? My hand's on one side, and then we got the sun hitting it on the other side. There's going to be a temperature difference, right? The one side is painted Fanta black. My hand's going to be a different temperature. There's no movement there, right?
There's no movement.
Your hand is alive.
Yeah. There's no movement.
Okay, we're going to make electricity off of this. Except what?
You got the photons coming in from the sun, though. I mean, if you're gonna get Peltier, fine. I'll just try to get a win on you. I'll bring the photon in.
You got pressure applied by the ether.
Okay, I got you. My hand's on one side, and the other side is up against ice.
Okay. I mean, look, the ice, it's going to move, right? There will be convection currents, even inside of your hand. There will be 100% convection currents. If there is a delta T temperature differential, then yes, you will have heat transfer. And because it's a vector, that stuff moves, but it's not tangible, right? But it's a vector quantity. Heat will transfer. Correct. Yeah, it's not heat. Can you grab me a fucking cube of heat? Like, I can't. It's not a tangible thing.
Okay, did I win or no?
You want what? Work? You want work being done without displacement, right? This is where you're going?
But in that Peltier device, you have electrons that are moving the heat across the junction. So you have the movement of the electrons that's causing the.
You'll never take that out. Correct.
Okay,
we'll never take out the atomic jittering.
They're acting like little delivery vehicles of energy.
If that's the case, then everything ever is moving, and you never have anything not moving. So what? Now what?
Yeah, that's what the modern mainstream presents.
You're saying everything is moving. I know, but you're saying when everything's moving.
But if a system
hold on, Jake.
Sorry,
you got 70 IQ. Relax, bro. Yes. Here's the thing. You guys are in the position Galley had Fundy in, where it's like, okay, now you have everything's moving. Nothing's not moving ever. So when Fundy gives his example of, when he's saying work's being done or whatever, or whatever he was saying, with no movement, there actually was movement, and he was right.
Yeah, but the problem is, I think Jake was going to go down, is like a wall, for instance, or a bridge. If we're going to talk about what you just talked about, that everything has movement, You go, okay, within that system that is the bridge, there is movement. But in and of itself, it's static. It's like a complete unit. It's static.
I think the more accurate thing to say is equilibrium. It's in a state of equilibrium.
It's in a state of equilibrium with respect to everything else outside of it, but within itself, it has its movement. So
everything's moving according to Syrus. Everything's moving. That means Fundy's examples of things doing work without moving, they actually were moving and they were doing work because they were technically moving, right?
Okay,
atomically, yeah. There's
a
motion.
Peltier device that has the energized Peltier device is not in equilibrium, right? There's an active current flow through it, so there's electrons that are actively moving through it.
You can use it like that, Jeremy. You can use it like that. It would be illogical because at that moment you wouldn't have anything to distinguish between work and no work. There would be no work because everything is moving all the time. Is moving. So when you will have that situation of no work,
can we go back to the internal equilibrium? So like the L-shaped steel thing, whatever the example before. If we're going to use what you're saying, Jeremy, that the thing has movement. The thing within itself has movement, but that movement doesn't leave the boundaries of the L-shaped object. It's contained.
I don't know about the L-shaped thing. That was Fundy's thing.
No, but just any physical object, right? If you're going to say everything has movement, sure, we can agree to that. But within any object or any system, that movement is contained and doesn't leave the boundaries of that, be it the physical bridge or whatever system that you're talking about.
I wouldn't say everything's moving. According to Syrus, everything's moving.
No, but he's not wrong. But like how you make that make sense in with the idea of something that's structurally passive and doing and like apparently doing stuff or not being affected by other stuff. The movement is in totality, like Jake was saying, it's at equilibrium. But internally, all the movement is bounded, either by the physical boundary of the object or by the system it's like at large.
Would you call it, Syrus, non-tangible movement?
Oh no, I was talking about heat. Yeah, heat transfers, but it's like, do you agree that heat transfers?
Yeah, I agree. That's a neat phrase, non-tangible movement. You know what I'm saying? I'm interested in that phraseology there.
And tangible.
I mean, electrical current
on the sensitivity of the device analyzing it.
You can appreciate.
Sure. I would agree with that. Yeah.
You can appreciate the heat transfer through a metal rod, for instance, right? But you can't. You're not tangibly appreciating it. You have a visual way of appreciating it because the glow of the metal is moving up the length of the rod, for instance.
I mean, you could see
all right, I got you. You know what? I got a toe tag. Let's see if you get this right.
You can see in a FLIR camera, if you got a FLIR camera and something gets hot and then it cools down, you can see something's happening for sure.
Yeah, but you can't.
Yeah, I mean, if you just bend a piece of metal and fatigue it, you'll see that it'll be hot after you just got done bending it.
You put in the heat though. You put in the energy.
You put in the energy. You pump energy into that lattice.
Yeah, before you do the toe tag, Syrus, have you ever seen how you can change the use length of like a drill bit, for instance, by putting it in cryo. What's like liquid nitrogen. So
for hardening or something like that.
Yeah. It's a neat trick. But anyway, carry on with your body tag.
Okay, toe tag. All right, hey Jeremy, do you think we can feel temperature or heat transfer? What's your body built for? Do you think you can you detect temperature with your body, or can you detect heat transfer? Which one is it? It's like a binary thing.
I don't know.
Don't bring me a third fucking option.
I don't even know. I would say there's some temperature you wouldn't even be able to feel. So, but I have no idea.
Here's a clue, Jeremy. Why is it that if you take a steel plate and a piece of wood at the same exact temperature, the steel plate feels colder? That kind of will lead you to the answer.
Exactly. I was going exactly to that.
I still don't know the answer.
It must be temperature. The
heat transfer.
Really?
Yeah, it's heat transfer. Yeah. So because grab a piece of wood, piece of aluminum, or same mass, whatever, or same volume, it does not matter. Put it in the freezer. Leave it for a couple of days. Grab a thermometer. Read the temperature of everything. It'll be the same exact temperature as the freezer, the environment, whatever that may be. Your thermometer will verify to you it is exactly at the same temperature. Now grab the piece of wood and grab the piece of copper. Which one feels cooler? You will let go of the copper immediately while you can still hold on to the wood because the heat transfer from the copper is so much faster. Thermal conductivity. Okay.
This is like sticking your hand in an oven versus sticking your hand in the same. Like if you had a 400-degree oven and then 400 degrees hot water, you could stick your hand in the oven, but not the water type thing. Yeah.
This is why you wear gloves, to mitigate the heat transfer, not to mitigate the
Heat
temperature.
transfer. Correct. It's you don't. Your body does not feel temperature. It feels heat transfer. Oh, I'm too hot. Oh, I'm too cold. No, I'm gaining too, or I'm losing heat too slowly. Versus, I need to lose heat faster or whatever. So because if you're gaining heat, you're fucked. Like you'd be gaining heat, like you're so fucked as a human.
It's a small thing, but I'm glad you brought it up because I would have thought it would have been temperature because the delta, but I was mistaken the delta for temperature reading rather than heat transfer.
Temperature is what drives.
I appreciate that little bit of clarity.
Man, heat transfer. Look, it's very easy. Heat transfer is a seesaw. The temperature gradient, right, between the two sides. That's your driver. That's it. It's that simple. Heat transfer is a seesaw. Imagine an imaginary cube moving from one material to another. Down the seesaw or up. Up, you got to spend energy.
That would explain why certain people can put their hands in like molten metals and stuff. Because they have a different condition for appreciating heat transfer to someone else because they got calluses or whatever.
Who can put their hands in molten metal?
I think you're talking about like if you've ever seen like those guys at the foundry that can pluck stuff out, they dip their hands in water and then they.
I've seen that.
Called?
Yeah.
Momentarily, you have the steam that forms on the surface that momentarily blocks the heat transfer.
Bad example because they're using. Hold on, bad example because they're using something else. But look at like your mom in the kitchen or something, or like some of these people. The fact that they can go and pick it out of the thing and you can't is because they've got calluses on their hands that you don't. So they have a different appreciation to heat transfer than say a baby would.
You're almost there, Elijah. You're missing 50% of the answer.
You use aluminium to create those spherical ice balls that you use in the bar to make your whiskey or your drink.
Oh yeah, the kind that don't dilute your alcohol. Yeah, they don't dilute your alcohol.
No, they dilute the alcohol. It's regular ice. But it's like a mold. It's like a mold where you put a piece of ice and then you have like the spherical thing and it like melts down onto it and forms like this perfect ice ball.
If you make it with plastic, with wood, it doesn't work the same. It will take
more education. I thought you were talking about the non-ice. Like you put it into a drink so that it doesn't dilute your alcohol. It's just like a frozen.
No, it's a thing in the bar. If you go to like a fancy upscale bar and they got. They'll have a thing where they'll put a block of ice on the thing and it'll slowly like melt into this like perfect spherical ball that fits right in your glass.
Yeah, that one. Yeah, exactly. Even if just
real quick,
a simple plate. You take a plate of aluminium and a plate made of plastic, another one with wood, and you put an ice cube on it so that it will melt faster on the one with aluminium.
Right, if you say aluminium one more time, we're gonna have problems.
Yeah, in the aluminium. When they were shipping ice, when they would ship ice around the world, they would line the hull of the boat with sawdust as the insulator.
Hold on, what's that? What is it?
When they would ship ice back in the days before refrigeration, right? They go pluck ice from a frozen lake and then ship it around the world. They would fill the boats with sawdust to put the ice in to insulate.
Like they would have the ice would be touching the sawdust.
I'm not sure how they isolated the ice from the sawdust, but like sawdust is a very good insulator because you get all the little air pockets between it, right? To act as an insulator.
Yeah.
You may
let me address Elijah right quick.
Just do it first.
Oh, I'm sorry. What? No, somebody was talking to him.
I just remembered the Ice King documentary. You may have seen that, and it described the impact that refrigeration had on his basic ice empire.
The ice cutters. He was shipping ice to freaking India, man.
Oh, that's mechanical refrigeration. That's what's up. Ice cutters thought their job would never go away. They're so essential to society. And nobody knows what an ice cutter is today.
No, they still do it. They still do it.
They do? Like out of the Great Lakes and store it in caves and sell it to you in the summer and shit? I don't know, man.
No, I mean not in America, but there's places where they're still cutting ice like that.
Yeah, that's pretty cool.
Not on a
back to the heat transfer.
Like where they make that ice hotel in Norway.
I haven't seen
no.
They do it like that in local environments. But go ahead, Syrus. You got to force your way.
All right, Elijah. No, it's okay, man. You got your cup of boiling water right on the stove. Grab your thermometer. Take a reading. It's at 100 C. I'm assuming you're at sea level. Okay. Now, dip your finger real fast in the water. Kind of nothing happens. But leave your finger in there. You get burnt. What's the difference? Temperature is the same. See, that's the answer to your question, Elijah.
You didn't get the transfer.
Time is the difference.
It wasn't long enough.
Heat transfer takes time.
Yeah.
Correct. Yeah. Time. Time is a big factor in heat transfer. That's what they call an adiabatic process.
That's why you said it. That's why you said
no heat transfer.
That's why you can put your hand in the oven and not in the water. the heat transfer doesn't happen fast enough.
Is that why you said it's 50%? Because the reason the catalysts allow that to happen is because it delays the time for the heat transfer.
That's thermal conductivity. Yeah, that would be thermal conductivity in the material. So you have like just an insulating layer of the calluses until it heats up the callus. Then it'll heat up the sensitive skin where you got your neurons, or I'm sorry, whatever it is. Not neurons. That's in the brain. Isn't that neurons?
Nerve endings.
Nerve endings.
Or you've abused them and they're all gone.
Right. Yeah, I've seen some. Not
you have
too
to
many.
You have to watch it again to make sure it wasn't just AI nonsense.
Right. I've seen foundry accidents. Those are just terrifying.
Oh yeah, it's craziness.
Terrifying, bro. The amount of energy stored in that molten metal is incredible.
Oh wait, the other one that I saw recently is the it's like rolled up plate steel or something like that, whatever they call it, and they have to deliver it in a certain way. So
coils?
Yeah.
Coil steel.
They call it the Widowmaker or whatever, and you're like, oh goodness.
Bro, there's so much tension in those.
Yeah, they can't
if it
store
just
it
uncoils.
They have to store it upright, because if they store it flat, then it ruins the product. But then storing it upright has feasibility issues, and you can either kill people or whatnot. It just looks like can we just not use these things? Is there another option?
Drop one of those down the hill. Nothing stops it.
Yeah, you're better off just taking the foundry instead of delivering it. Just like, well, why don't we just deliver a factory here where we can make it on site? Actually, that's part of the problem, isn't it? That people outsource so much. I mean, isn't that like the Globus fundamental problem? They've outsourced their thinking to NASA.
Yeah, eating and chatting at the same time. Dude, that's too many toe tags in one day, Jeremy. It's a lot, buddy. Is that like 5 or 6? How many? I lost count.
Yeah, Jeremy, if you're a cat, you're running out.
Dude, I got more shit, but if you think like electrons and photons and shit is like movement, then there's nothing you could do.
Until proven otherwise, or I don't know, man. I can't just dismiss all the morphology stuff.
Because
I'm not saying dismiss it, but there's like nothing moving there. Like electrons moving. Come on.
The thing is, when you go down to that level, you're actually going past the use and the boundaries of the words that we were using previously. Because if you look at an example of the simple mechanics that was being spoken about earlier, that's completely a different category to, what do you call it, morphology, Syrus?
Yeah, morphology.
The fundamental essence of that which makes up mechanics. It's got to be its own area, and then every word that you're going to use has to be redefined within that context.
It's all electrical. When you get down to it, like you see, all right, nucleus, you got your neutron and your proton, and how the fuck are these held together? All the answers are electrical, or how are these electrical corpuscles, or whatever J.J. Thomson called them, right? Corpuscles, yeah.
This is why I like the way
it's just a quantity of electrified. We don't know what the fuck it is. We just label it electron, proton, neutron, based on charges. Okay, cool. And you can do experiments to determine that shit. Cool. But dude, what holds material together? What makes materials up actually is a quantity of what they say is how many electrons to protons to neutrons. It's like, damn, it's electrical stuff. This is what makes up morphology. It's like, what the fuck? We don't even know what electricity is.
Right. That's why I like one particular quote from Tesla. It's like, I don't know what, like, speaking about resonant, whatever he called that type of electricity. I don't know what it is, but it seems to behave like a fluid under pressure. And that seems to is precisely the reason why you can't use what we're dealing with now in a categorical sense to the fundamentals, because it's a different context. Like the way the phone falls out of your hand and like lands on the floor and cracks the screen is different. Like the way you're going to describe that is different to the internal structure of the glass that broke. It's a different category altogether, and you can only talk about it in what would you call it? What's the overall word for like similes and metaphors and that type of stuff? In comparative language, that's it. You can only talk about it in comparative language. You can't talk about it absolutely, because we don't, at least as yet, right? We don't have the capacity to establish absolutes.
We don't have a holistic unified theory sort of thing. We really don't know.
And that's one of the issues with this modern nonsense with scientism and stuff, is they've smoked all the hubris they could possibly smoke, whereas all the legends that they stand on, they never had that type of hubris. They always were honest with how far they could go with what they said and what they understood.
It depends which book you pick up. Again, which field are you studying, man? Like ideal gas, dude, they tell you there's no such thing as an ideal gas, but we proceed to it's close enough, right? We've discovered, hey, it's actually really dang good, but there's no such fucking thing as an ideal gas. Which one is it, huh? It's like maybe one of the gases or something, but like the atmosphere is a mixture of gases. So, but we just treat it as a fucking ideal gas, get it over with, move on. It's like it's close enough, you're within 1%, right?
For practical purposes, that's good. But they make that clear, it's fine. It's when they stop making that, they're just saying it for practicality's sake, and they're actually doing something. It's when they start talking about electrons. Yeah, when they start talking about electrons and all this stuff as absolute states of reality. You're like, hold on a minute. It's only been a few decades since when these books were first released that they were saying this is our theory and this is what it appears to us, and this is they had the intellectual honesty to describe it as such then. Now all of a sudden, the people who don't even know where it came from are telling you, no, this is how the world works. Hold on a minute. So I don't know who it was, whether it was Dollard or Lindemann, but one of them or someone in that group he was reading from one of the original textbooks, establishing or presenting the theory of like the electrons and all of that stuff, and just the difference in tone that they approached it with, of this is the theory, this is how we understand it, and this is what we could extract and why it makes sense. And then fast forward a few decades, and
like the electron flow in the wire. I mean, like when you talk about materials and morphology, cool. Electrons, protons, cool. Talk about electrical flow, ditch it. That we get perception of electron flow due to remember the friction of the dielectric flux moving down in space and scratching along the wires, so it produces heat. It heats up the wire because it's JJ said it's attached to an electron, so it's kind of like grabbing an electron and like dragging it along, but it's not dragging it along. Electron is like what he thought of. It's a terminal, right? One end is a proton, the other end is an electron. As it moves down between the conductors in space, it like moves from terminal to terminal, but we get the perception of, hey, the terminal is moving, the plug, right, where it's plugged in, the electron. But the fabric is actually what's moving. You can say that it's what moved the electron, or you get the perception of electron flow due to the flow of the fabric, which is the energy, right? The energy sits in between the conductors. And due to the energy flow, scratches the conductors, causes it to heat, and all the good stuff, and gives you perception of electron flow, has a velocity and all that good stuff.
Yes, I've thought about this whole thing with the ether, and I'm of the opinion that I think you could understand it better if you allow yourself to conceive it as there's a sub ether, or like a baseline ether that manipulates the high levels, if you were. And so what you were describing with the lines of force, that would be like just above the sublayer, and it's been manifested in that manner by the sublayer, but it's all kind of the same. It's just where it's getting its information from. Does that make sense?
Yeah, it is the same. It's just from which angle are you looking at this from, right? Like, you can use the Glober frame of reference. Are you in the wire moving along the wire in the electron, or are you outside the circuit observing the entire motion of the whole energetic system? So sort of where you stand. Because you do get perception of electron flow. Is it perception or is it electron flow? Okay, electron flow. Okay, is the electron attached?
You're all brainwashed by this bullshit relativity shit, dude.
No, we're not.
No, it's not relativity. This is electricity.
Cyrus is. Yeah, but you're saying, and is the electron moving or what? What's the other one? Is the air?
Yeah, motion. Yeah. Okay, so look, they say it's not totally analogous what I said, because the mainstream tells you electricity is a flow of electrons in a conductor. Cool. The original understanding, and which half of it still stands, right? Like they will tell you the energy sits outside of the conductors, which it absolutely does. You can measure it, the fibrous structure. And that whole fibrous grid moves when you have current flow. The original understanding from JJ, the discoverer of the electron, or one of them, right? They got the Nobel Prize for it. He believes that's the terminal. The electron is just the socket where this dielectric line of force connects to in the material. This is where it terminates. So as that line moves down, it gives you perception that the terminal is moving.
Yeah, all right. JJ Thompson, I think either his dad or his son also won a Nobel Prize for something. I think it was for the opposite thing that the other one did.
Oh, I don't know.
What do you win the prize for?
I'm not aware.
What did JJ win the prize?
Just him and Rutherford for the discovery of the electron.
Yeah, it's called. There was they qualified it some way. That's the finance. Everyone else.
You're roboting.
I suppose if JJ made any mistake, it's giving it a name like an electron, because it allowed the simple or the manipulative mind to extract that from from what it was supposed to be to, hey, this is this individual entity and it exists probabilistically. If he'd chosen a different name and been a bit more considerate, it's not as if it's his fault, but if there was any error to find, that would be the error.
It's not a big deal.
I know it's not the people who actually study, but the problem is nobody reads the literature. So what? It's one thing to not engage with something and say, all right, well, if you're not going to engage with it, then you don't need to read the literature. So if you're going to talk about Abraham, go and read the book. If you're going to talk about electrons, go and read the book. You know what I mean?
Agree. Yeah. You can talk about potential energy and work. Go read the book. So I agree.
Yeah, J.J. Thompson's son also won a Nobel Prize.
All right, for what? I didn't know that.
For showing that electrons behave like waves.
Oh, that's a setup. Never heard one.
Setup, right? Bro, that screams fucking reset right there.
But if his
son just happened to both win Nobel Prizes with electrons.
It's good though, because he's not going the particle route, is he? You see, it's like it behaves like a wave, which is he's going with his father.
Yeah, but they say it can't be a wave. Don't you have like
yeah, but that's they.
Maybe that's with photon. Maybe that's with photon. Yeah, but this is mainstream shit. They are the they. Don't they say it can't be a wave because of the it's maybe with photons though. Is it Compton scat? Do you have Compton scattering with just photons, or is that electrons too?
Both. I think
it's just photons.
Whatever.
Is it just
I
photons?
Believe both I think both do the same thing, photons and electrons.
What about the ultraviolet catastrophe? That's just light, right? That's not electrons.
Oh, that's an electromagnetic wave. See this? Hey, the photon again. I'll use photon, but I don't believe in it. Like I'll still use it to model things. Sure. When an electron drops in energy level, it spits out a photon. Okay, I get what they're saying to quantify this shit. But nobody's fucking observed this electron jumping down orbital and kicking out a soccer ball, calling it a photon. No,
because what actually happens is there is an inducement. There's an inducement, and that inducement results in. But they're so lazy. They don't want to use these. They don't want to use these words, right? They don't want to admit the medium that you're even able to exist. Like without the medium, you don't exist. Forget transfer of light. You don't exist without the medium. But because they don't want to acknowledge that, and they're too lazy, they just butcher everything. Sorry, go ahead.
I disagree with the mainstream, Jeremy. By the way.
If you're saying no, you're the mainstream dude, bro. You're the mainstream guy. Yo, if nobody's
Newtonian
mechanics, how did
mechanics.
Einstein win a Nobel Prize for? Hold on. If no one's observed that, how did Einstein win a Nobel Prize for the photoelectric effect?
What did he observe?
His cousin.
You said no one's observed the
electron jump in orbital. Yeah, I want to see this. Like this is good shit.
Oh, and you said electron. I thought you said something else.
Yeah. No, that's how a photon is created. A photon is created.
They already said electrons aren't orbital. They got rid of the Bohr model. I mean, they still teach it in schools, but they know that's not
in energy. In energy level. All right. Cool. We're going to replace that with what they call energy level. So when the energy level drops,
they got rid of the orbit and replaced it with a cloud.
Right? Somewhere in there, we don't know exactly where. Yeah.
But it's not. They don't have it orbiting
distribution.
Though. Yeah, but it's not orbiting though, right? Anymore, they have it just like where it is. We don't know.
It's more magical. It's more magical than orbiting sphere of nothing. Okay, it gets even fucking worse. What cloud of what? Oh, probability of what? The electron being there, which is made out of what? Electrical charge. Which is, bro, it gets fucking difficult. Then you go into it's made out of quarks and shit like that because no one understands what electricity is, and it seems to be the fundamental building block of everything around us. What is electricity? Not electrical flow and energy and lighting light bulbs. No. What is the shit that we're dealing with?
Have you heard the idea that there's actually only one electron? All these
No, I don't know.
electrons we think that are out there, it's really just one electron.
Just really fast, going everywhere.
No.
It's
Singularity
smoke
electron.
that-
What is this?
I
Actually
want to
travels
smoke
through
that
time
kind of
is the
current. Hey, but
What's up?
I was,
Hold on, the new guy, the other guy that wanted to get in, what'd you say? 3 pi what?
no, that was yeah, what's my name in this channel? Roundhound. Yeah, I find those sort of postulations really fun to think about. The theory I think that you were alluding to was that there is only one electron and it travels through time backwards and forwards to build up everything we see. So I know it sounds crazy.
Yeah, do you know the name of that?
It's a fun thought. No, I don't know. I haven't thought of it for years. You just reminded me of it. It's
Yeah, I can't remember the name of
that.
it.
this is what happens when you give meth heads university grants. They say all sorts of retarded stuff.
There's
Hey,
nothing
so-
to say
going
that
back in
it's not
time.
how it is.
It went back.
Sounds preposterous, but there's nothing to say it's not what it is.
So is it like positioning, or like what do
It's
you
called
mean
the one
going backwards in
electron.
time?
It's called the one electron
travel.
universe It's called the one electron universe hypothesis. But that's not the name I remember, though. I remember a different name.
But hey, here's an example on a practical sense. So you know they call them LEDs, right? They really should be called light inducing diodes. They're not emitting light; they're inducing light. This is actually case in point to the misunderstanding that the majority of the world has. You don't throw light anywhere; you induce it in the medium.
Another really interesting thing is look up blue LEDs. It's like nearly impossible to make. It took them decades to actually work out how to reliably.
Yeah, the blue LED's dope. I'm looking into this. The blue LED was crazy, but hold on real quick. I'm reading on this thing. It's called the Eddington number. He got it. He got this Eddington. You know, we all know who Eddington is, right? He got this number using dubious physics. What's that? Sounds like everything the fucking Globe does.
Oh, he was a fucking fraud.
Dubious
The weather
physics.
report was cloudy on his day. On that observation, it was cloudy, dude. It wasn't. He's a fraud. It's always
Wizard
been.
always brings that up where the plates from that. I want to get into observatory plates when we have a moment. But yeah, Wizard always brings it up that those plates don't really show what people think it shows.
Of course not.
Syrus, observatory plates.
You're talking about the shift, right?
Yeah, for GR. He did the big GR thing that supposedly validated GR. Observatory plates, right? All done on plates. And then we went digital at some point. However, they went back and looked at all these plates. They found something orbiting Earth before we were in space. On the plates, they checked it, they double checked it, they pulled out anomalies. Like they went through this shit because they're like, yo, there can't be anything orbiting. We didn't send anything in space. Sabine Hassenpfeffer did a video on it.
Yeah.
That's crazy. The mainstream found something orbiting in space before we sent things into space. Where did everyone go?
Where do you think the idea of the Death Star came from? I think they just pulled it out of their ass. This is an old story, man. Old story. Olympus.
What happened was you entertained fundy physics for too long, and everybody left. That's what happened.
His name should be changed to Fundamental Misapprehension. But that encapsulates his whole thing.
He brought up that topic. That was a crazy topic. It went for hours. So
it only went for hours because he doesn't know how to shut up.
I asked the Globers that same exact questions, kind of. But I asked them, where did the energy come from for gravity to pull things down? So, okay, atmosphere is stuck. We have a gradient. Cool. It's due to gravity. All right, cool. Magical bungees pulling down, the sphere of hydrogen or whatever. All right, cool. How does the bungee keep on bungeeing? Which is an energy question. It's not a work question, right? Where's the energy coming from? Einstein answered it for them. He said E equals mc squared. That is the correct Glober answer out, right? But that doesn't actually complete the picture if you really want to know, right? It's like Tesla said, matter has no energy besides that which it can receive from the environment. Tesla had a totally different fucking stance from Einstein, 180 degrees from him. So, and I of course, because quantum mechanics is agreeing with Tesla.
It's no mistake that gravity and gas pressure without containment go hand in hand. because when you go because of what because you cited Tesla, right? His position is that there's a groundward etheric pressure at work. You don't have that if you've got uncontained pressure systems next to non-existent pressure systems, however that works, right?
I guess. I mean, man.
Because that's
I
it.
don't
But that's
know.
just it.
There's a lot of stuff that I don't know here.
Because even if he didn't like vocalize it or whatever model of the world he actually had in his head, when it gets down to brass tacks, his position on gravitation, not gravity, because that's a misnomer in and of itself, but gravitation, was that it's because of a groundward pressure, a groundward etheric pressure, and then all these other things are as a result of that.
Right.
So if that's his position, then I think if he actually took the time and if he was alive today, it wouldn't take him too long to go, oh yeah, we live under a dome. Honestly,
Yeah, with the
it'd be the
equipment we
easiest
got.
thing for him. Yeah, because he's dealing with the fundamentals all the time. He's making it happen. Things that no one else either has the patience or the capacity to make happen.
Okay, I got a question for you. Just as long as there's no
take
Globers in the room, we should be good.
we can just
I know you believe in the firmament, and I like religion plus science, because there's a lot of unanswered stuff. So maybe the religious text can help us, right? So, do you have a problem if the firmament is a force field?
You'd have to elaborate on what you mean by force field.
What do I mean? Okay, well, like my religious subscription, God says it's made out of woven string, watertight woven strings. So, like, I'm wondering, is that electromagnetic? Like, so I'm going to assume, why not? I'm assuming electromagnetic.
Electromagnetic.
Yeah, but it is, but like, how I'm talking to you right now, there's a specific wave going out with it. Like, it's not just nonsense. It's an ordered electromagnetic structure flowing in space, right?
Yeah, okay, I can answer that quickly. So I suppose within the framework of where it's acceptable, the way you're phrasing it would be like a condensed etheric textile, using your words, right? That would be acceptable.
Let's say electromagnetic textile, but that can repel water and material.
Yeah, so
it can behave like solid, but not being quite actually solid.
Because of what I know about the ether and all that stuff, that would be acceptable to me. But you would have to be very specific in how you describe it. But my fundamental position is it's not necessary, though it's probably plays a part because of other things, because this is a dynamic system that has a lot going on if you read the scriptures, right?
But I know you're scientific headed.
Let me finish.
Go ahead.
Because it's necessary to understand. Though I think it would be it would play a part like this. The manifestation of like an impermeable state of the ether, because the ether in and of itself permeates everything. So it's the baseline, right? But from my understanding, it puts itself in positions that we see on ground level of like setting boundaries. Like the magnetic setup is a good example of this, right? So it's making its own boundaries and its own void points. That's interesting. But anyway, but fundamentally, from my position in scripture, it's a physical crystalline structure that is an immense, especially the first firmament. That's an immense operation.
Like crystal, like glassy, like solid material, actually.
Yeah, like sapphire, but maybe sapphire in like a heightened state.
Yeah. Improved. Yeah. I know what you mean. Like something improved, whatever the reason
I wanted to like qualify that with what I understood from what you were saying is because there's parts about its structure in operation. So say the flood account, and then the angels traversing, and then how are you going to maintain pressure and all of this? I'm like, well, I understand that a being like that has the ability to pass through this stuff because that's an ether being. So okay, that allows some flexibility. But if you're going to have if you're going to have the need for structure to be maintained, but also permeability, you're going to have some funkiness going on that we don't really have a solid grasp on down here. But I would say that if there is any way to understand it, it's that.
We do. Semi-permeable membrane.
Crystal, though? Yeah, but crystal.
Hey, that's God stuff. That's what I'm saying.
But that's what I'm saying, right? Because if I'm understanding it within this framework, within the text that we have at hand, if it's crystalline and it's displaying some sort of permeable ability, then the only way I could understand that is with the way I accepted what you described as like condensed etheric textile or whatever.
Something. Yeah, you grid.
That's as far as I can go because I can't put it in any solider terms. But where I think some of the issues are alleviated is that there's not just one firmament. My structure and my understanding is that there's seven.
Seven. Yeah. I just wanted to see because, like, you like science and religion, so do I. And this is where I try to understand all this religious stuff, of course, with a scientific lens, 100%.
Oh, you should read Wisdom of Solomon in light of what you know about ether. It's hilarious because it talks about it's talking about it as a her, right? Which that's its own story altogether. But it says she permeates. I think it even used permeates. It just starts describing the stuff like this is the ether. So this is, and it's because
what is he talking about?
He's talking about wisdom.
Call it? Ah, okay.
Yeah, so no. The whole book is about wisdom, but he's describing what wisdom is actually doing in physical language, and you're like, the only thing that I understand that could to possibly be is ether. So it's things like this,
gamma rays sort of thing, yeah. Ether.
It's readings like that, and then all my understandings of the physical stuff from Tesla and the rest of it that lead me to this conclusion that the ether is like it's a category, and then within that category there are layers, and there's like that base fundamental one, which is the essence of the creator, and then there's like other ones within that category that are either above it or below it, depending on which way you view the hierarchy, which is not really important right now, but just that they're within that larger category, but they're slightly distinct in let's say manifestation or operation. Because I would say that wisdom is secondary because the creator comes first, but wisdom operates in the same physical, quote unquote, or tangible manner that what Tesla was dealing with worked. And then, to be honest, it's kind of almost becomes indistinct because it's like, well, how is it going to manifest? Because if you look at wisdom from a loose, like colloquial sense, you're like, well, you can apply wisdom to get wealth. You can apply wisdom to get healthy. You can apply wisdom to physically do things that were otherwise difficult with just brute force. So I don't see the issue there. But I don't know if all of that landed. But I don't want to talk for too long because
most of it
might get lost. That's enough.
Oh, that's cool.
If I'm understood 100%, if I'm understood 100%, then I'm talking to myself. Cool. But yeah, it's fun. It's very fun. I would argue that that's the only way that you can understand some of this other stuff. So I don't think it's. I thought it was clever. I thought it was clever.
Where I can.
Hold on. I thought it was clever when you responded like, "Oh, that's outside my wheelhouse." When Jeremy presented that thing of the nuclear stuff. But I think with the fundamentals that you already possess regarding the ether structure and manifestations, that you could actually build a viable understanding of why that thing's just giving off energy all the time.
Oh, for sure, but for the sake of discussion, it's okay.
Yeah, but it would only work if but it would only work if you could talk to somebody who can comprehend and acknowledge.
Oh, you're saying he can't comprehend it? All right.
No, not to Jeremy, because that's not why he brought it up, but just to explain it within that framework of the ether and all of that. I think you could, without actually having to physically investigate that particular element or whatever. I think you could build a viable understanding just on the principles that we already know.
Totally.
But that's
thermal
easier.
Energy.
Yeah, it's easier said than done, though, right? First principles, just talking, because this is where I'd argue that you kind of, if all you're doing is talking, then fine. But if you're talking forever, then it's a waste of time. But if you only have the option to talk, then cool. But at some point, you have to not fall into the trap of doing what Einstein did, right? Which Tesla rightly mocked him for. Right? These guys never experimented. They never did jack shit. just chatted noise all day long. But I think you can establish a lot with first principles by simply sitting down and talking. You must have done that at school, right, with maths? Did they run you through the script with how everything that you've now just got at your fingertips on the calculator? How these guys had to work their ass off years and years ago to
Not
build
everything,
it up.
no. They taught the fundamentals. Some fundamentals.
They did that for us with
carry on. You know?
Yeah, they did that for us with the trigger I can't remember the term now. Sine and cosine and all that stuff. What's the name for that? It is trigonometry, right?
Yeah, whatever. Trigonometric functions.
Yeah. It's like, do me a favor.
Call
Imagine having to do that. Imagine having to go back to base to do that.
Instead of just the easiest shit ever.
It's like, it'd be you
want to use tables? The sign? Yeah, I mean, it's easy, but you don't know the ratio, right? Trying to get the tan inverse or the sine inverse. It's like, okay.
You have the knowledge, it's simple, but it's not easy. It's a different stuff.
And then people end up making tables. You gotta go through the tables and shit.
There's better math systems anyway. I remember watching an interesting documentary was like extracting maths from ancient architecture. He must have had other understanding, but he was using it. That was the documentary basis.
They still use the abacus, man.
And it was the one that got me that I thought was the most interesting was instead of doing the equation for pi, which is just ad infinitum decimals, which I always thought was retarded. They were doing it as a ratio, as a relationship. I was like, that makes more sense. That makes a hell of a lot more sense. But anyway, I can't remember what the documentary was.
You can.
So
that's why I like Oliver Heaviside, man. He's the man. Oliver Heaviside. He said, bro, this guy said you can make up your own mathematics as you go along. However, you have to be able to trace your way back. Okay, if you can't trace your way back in your math, you're fucked. So you as long as everything is correct and checks out, you can make up your own mathematics. And bro, he wrote the curriculum of electromagnetic theory, that nobody understands. So it's like, I like this guy. He's a fucking genius. And when a genius that I respect tells me, it's like, fuck everything you know. You can actually do your own. Just, and he gives you the rules for it. It's like, this is how you correctly do it.
It puts a whole new spin on show your work, right?
Like Einstein, you can solve it for an empty universe. Bro, look up, motherfucker. Look, yeah, solution is correct. You got stars. You got sun, moon. Okay, your math is trash. Start over. No, it's whatever. They just, let's correct the math. And this must be right. It's like, oh man, or correct our understanding. The math must be right. That's what they do. No, it's upside down, man.
Yeah, the maths is only as good as the assumptions it's built. The problem is we went from being in physics class where you had to state for the paper or the exam question the assumption, or you were given the assumption in the question, to people just making statements, not even realizing that it's founded on multiple assumptions.
Assumption.
And then you have to unpack the assumptions that they don't even know that they have. Now, hold on a minute. Yep. I'm not your daddy. What's going on here? Bunch of
that's the best thing my dad taught me about engineering.
They shouldn't be speaking.
He told me engineering is a state of mind, not a degree. All right. So if you're not thinking of assumptions and people making assumptions of shit, like you cannot be an engineer fundamentally. You just don't get it. There's always assumptions baked into shit.
Assuming this steel isn't from China, if I build the bridge like this, it will stand.
Right.
But then again, these people, with their thieving ways, we don't know. It might crumble at the first blow of wind.
Right. Material could be something that it's not. So yeah. Unless you verified the material, then you made an assumption that whatever alloy you purchased from China is that alloy. You have to accept that you made that assumption. Did you verify? No, then okay, you assumed.
This is why it's so ridiculous. Some of the way these people approach it. Because hold on, you can't even sell a cardboard box without it being quality assured. And then if there's a failure, then someone's in trouble. There's liability. There's money at stake and jail time, depending on circumstance. Right. And yet these people want to just start saying stuff. It's like no verification, no nothing. It's like, even in this corrupt, ridiculous world that we live in, they don't even try that to the extent that you're doing it. And you want us to believe you, and you're talking about reality as a whole. Do me a favor.
Yeah, no way. No thanks. No thanks. I'll listen when you start getting many pieces of the puzzle correct. But if you're just wrong from the beginning, it's like, all right, buddy, and you want to teach me, hey, this is what the puzzle looks like. It's like, dog, you don't even know what the pieces look like. All right, so that's where I'm at with these guys.
Yeah, special needs for sure.
Well, we can always assume. Like, I assume Earth is flat. Have I verified 100,000%? No, right? It's like, why? But with motion bit, like, I don't need to assume that. I know it's a 50-50, but based on my observation, I'm moving. Shit, cool. I can assume the stars are moving and kind of be confident in my assumption. But the other guys will say you're absolutely incorrect. It's like, did you stand elsewhere and see what is rotating around what? It's like, no, we haven't. And it's like, fuck off. Oh, they did. They went to the moon. Ha ha ha. Whatever.
I'm more unwavering on that type of topic because it's not an assumption to say that the stars are moving. It's an observation.
Oh no, they move. Yeah, but you can assume that it's 50-50. Like it's either I'm moving because of the relative motion thing, constant speed, no acceleration. Okay, that's fine. Yes. So you can go down that route too.
The only two options for me are they're moving or you're drunk. Pick one.
Yeah, you're drunk. Yeah, the floor moves. 100%. Hey, floor is moving and the stars. But yeah, based on observation, yeah, the stars are moving. I agree.
You're very limited in your ability to think.
How they're moving, that's an interesting question. But hey, that's beyond me.
Go ahead.
I think very limited in your ability to
somebody's presuming to
lecture. Look at it, think about what could happen.
No, we can assume other stuff. No worries. We can come up with other scenarios. It's not we don't have limited
like the Earth
thinking.
Is turning, like the stars all that are relatively motion still, and the Earth is turning. Right? That could be a scenario, couldn't it? That would explain the.
And I said 50-50.
That would explain two star rotations on both poles, wouldn't it?
I would say it has equal validity, 100%.
No,
both are
constant
motion.
Have equal validity. Cannot have equal validity.
How do you know which one is moving?
Because in a flat situation where all the stars are going around the central pole, around Polaris, that's impossible for it to also be spinning at the anywhere from the facing south. So
wait,
no, there's no possibility.
You're saying we're limited? That's funny. You can only.
No, I can have a stationary. I can have a stationary sphere with a celestial sphere rotating about the same axis. No, I can also have that.
No,
scenario.
You couldn't. No, that wouldn't work.
Yes, either. I can.
How would you
tell me? No, he solved it. He solved it for geocentric sphere Earth just fine. He solved all the motions correctly. What's the problem with that model? Sphere Earth. I went sphere, bro. I'm going sphere Earth. Geocentric, stationary.
He's saying the flat one he can't do.
Sphere.
Yeah, he's saying the flat one won't work.
And of course, that gets that hypothesis gets ruined as soon as you put a satellite in orbit.
Yeah, but just having the option of Earth being a sphere and the celestial sphere is moving. Well, there you go. Then which one is correct? Let's go somewhere else.
Well, that's okay from somebody making an observation, but as soon as you actually do something about it, like put a satellite in obvious use, you realize that one of them is wrong.
Right. Oh, okay. I'm sorry. Yeah, you're right. You're right. I haven't put a satellite up there. You're right.
I mean, go ahead. To be the heliocentrists, when they put a satellite in orbit, they don't know if the satellite's moving or it's the Earth moving.
You must be joking, right?
Space moving up towards the satellite.
Cyrus, tell them about the relative motion.
The way
this is your point.
I don't think when we launch a satellite, we don't know that the satellite's moving.
Back to the tree.
You think we know that satellite's moving when we launch a satellite?
Yeah, you guys have no idea what's. You guys never have any idea.
Space is falling around it.
You guys never have any idea what's actually moving. Can you hear me, bro?
Yes.
Yeah, you guys have in the mainstream idea of this relativistic paradigm. You never know what's moving, even when it comes to a tree in a car or somebody throwing a baseball. You never know what's actually moving.
Well, we do know what's moving with the satellite.
That's what happens when ether hurts people.
Space.
That's because
space can be falling.
We put it into orbit, moving. It was moving
space
when
can
we
be
put
falling
it
around it.
Also,
you never know what's moving.
There's no could be. We know what happened because we're the ones who put the satellite there. God didn't do it. God didn't make the satellite. We did. We know exactly how we put it there.
I don't know why. I'm telling you, space is moving around the satellite. The satellite is not moving at all. You perceive it as moving.
Well, basically, it's not.
Space-time is moving.
We made the satellites. No, we made the satellite move.
No, that's what you think. Earth is falling towards the satellite, and the satellite is falling towards Earth.
I know, 100%. I'm extremely familiar with it. Not like you.
How many satellites? All right.
Hold on.
We have a space monkey in the chat.
It's not necessary. It's not necessary, Elijah. I've had a PhD tell me that if a car and a tree are coming, or collide, that he doesn't know what's moving, what actually moved the car or the tree. He says it's actually silly to ask what is actually moving because you can never know what's moving. This is coming from a PhD physicist, and we made.
Can I answer that? The person who's watching, the physicist is not wrong. The physicist is what his physicist is saying that if you are the observer on one of those reference frames, you can't tell which one, whether you're moving towards it or it's moving towards you. That's correct. But when you're away from it and you actually cause the thing to move, you know that the tree doesn't move, don't you? How come you know that don't you know that the tree doesn't move?
The PhD didn't know that. He doesn't know if the tree.
You found a PhD who thinks trees can drive like cars.
Apparently, yes. Yes.
You found a PhD who thinks trees can move around like cars?
This is good.
Yeah, I guess so. Yeah.
You know the tree is still. Just like
I know the tree is still. Me and you know the
tree
still.
Just like we know what the satellite's doing when we put it up there. We know what we're doing because we put it up there. God didn't do it this time. Wasn't God. It was us.
Why you keep bringing up God, dude? He also said that if you throw a baseball, we don't know if the baseball's moving or the whole stadium's moving and the baseball's still. Even though
I told you the stadium
move, right?
You came across an idiot.
No, stadium fell around it.
He's a PhD.
You can't disprove that space time. Yeah, space time is falling around Earth. Like, go ahead, go fucking disprove that shit. Come on.
Yeah, what's
That's what they say. I don't fucking know. I'm going full globetard right now because that is their position. What Jeremy's saying. That is correct.
You're the main mainstream dude, yeah. Let him have it. Let him have it. I'm just saying, in the Glober paradigm, the mainstream paradigm, you never know what's moving. In fact, it's silly to ask what's actually moving. You never. That's what the PhD physicist told me. It's silly to ask what's actually moving.
Anything to admit that the ether is moving. Anything.
I go outside, I see stars move. I should not. It is very silly for me to ask what's moving. I will never fucking know according to physics. I have to go stand in a universal stationary, I don't know, reference frame.
It's not silly to ask.
Book me a flight. I'll go with you.
Bro, they reject the absolute.
You went on your satellite. I've never been on your satellite. I mean, did you send that shit up yourself? I don't know what the deal with your satellite is.
I was there. Yep,
okay.
Yep. I had a lot to do with it.
You were there?
Wait, in outer space?
Did you did you glue the fins on the rocket?
No, it was on the rocket. Exactly. Put it on the rocket. Deployed the satellite at its proper orbit. The satellite was the rocket was moving at the correct speed. When it let go of the satellite's still moving, and it's doing it up to this day.
How high?
So we made the satellite move.
How high?
Is it geosynchronous?
There's various ones. There are geosynchronous ones and unsynchronous ones.
How many?
You said all kinds. Holy shit!
How many meters above sea level?
Around about 36,000 kilometers for a geocentric satellite.
So it's not moving with respect to Earth.
Yes, it is.
No, it's not. It's geosynchronized.
It's moving with the. Yes, it's still moving. You don't think the geosynchronous satellite moves?
Fuck no. No, space. Fuck no. Space moves around it. No, it's fixed with Earth. And then space time is moving around everything. Get the fuck out of here, Einstein.
Here's the day you learn something.
Oh,
the reason that
you're learning your own model.
I'm a physicist. I am a physicist. The reason that it's a geostationary satellite is because it goes around the Earth at the same speed that the Earth goes around. That's why it stays geocentric.
When's the last time you did an actual experiment?
I said geosynchronous. If I'm not mistaken. Maybe I got my terminology incorrect. The geosynchronous satellites do not move position with respect to Earth. Where I am on Earth, if I look up. Well, it wouldn't be geosynchronized with it. What's the other one? Non-geosynchronous?
Yes, it's synchronized with the spin of the Earth.
So it's not moving relative to Earth, right?
It is moving. It's not moving relative to Earth. It's moving. That's what I said. At the same speed that the Earth is.
So relative to Earth, it's not moving.
Yeah, relative to Earth, it's not moving. Correct.
Yeah, and then space-time is moving around.
That's what you said.
That is actually what I said.
No.
Maybe you just missed it. You're too angry, so you misheard. It's okay.
Yeah. The Earth is not moving and the satellite's staying still. That's not possible.
Why not? Earth can be moving towards the stars. Attraction. And the stars are
the only reason that the satellite stays up there is because it's in motion.
Right,
it has to be in motion. The satellite is in a balance between centripetal force and gravity. That's the reason that it stays up there.
Oh, it's a Zen satellite now, right? Yin Yang. It's at one with the universe.
Are you guys actually interested in learning anything, or you just want to parrot off Nathan?
Rob, you didn't start to speak to teach us anything. You presumed to lecture us in the middle of our conversation.
Okay, all right, keep going. I'll be quiet.
The only thing that's moving is the ether. Apparently, this hurts people's feelings, Syrus. They can't handle it.
No. I'm gonna go with this guy. I'm gonna go ball Earth, geocentric. Everything else is moving around me.
Is it a hairy ball?
All the math is worked out perfectly. It's the same gravity ball.
Yeah, but is it the left ball or the right ball?
It's what? Pear shape.
It's the right ball then. Yeah, at least when Trump says he built a tower, you can actually go and walk in the tower. You can see it. You can touch it. You can throw bricks at it.
All right, what's the topic?
Nah, there is no topic when people start talking about satellites, man. Who cares what you put in the air? You didn't. Just because you put it in the air doesn't mean that the narrative that you believe surrounding it is any more or less valid just because you did something, right? If I have a narrative surrounding this glass bottle that it's made of fairy tales and, fairy hearts, right? And then I launch this glass bottle at someone's head. I go, look, see, I launched it at his head. That means the narrative that I attached to it is true. So, well, no, you just launched something at someone's head. The narrative is just a narrative. if the narrative has any value, its value has to be on its own merits, irrespective of whether you do anything with that narrative or not. That's what they fit. That's it's nonsense to you because you.
That's just
It's nonsense
gibberish.
to you because it's nonsense to you because it exposes what you were talking about.
No, it's just gibberish.
Well, if it's gibberish, why don't you steelman it?
Sure. So what you're saying is that just because we worked out that I don't know, atoms exist, this tube of silicone in my hand. I'm saying that it's made out of silicone atoms. Now I throw it away. It's not still made out of silicone atoms.
You want to try again?
What? Yeah, I got lost halfway through the silicone.
Doesn't matter. It's gibberish.
So it wasn't
of course you can tell. We put a satellite in space. You know what? We make that satellite move around the Earth. We make it move around the Earth.
You're doing it again.
Okay?
You just fail to understand. Just because you did something,
which part don't I
is
understand?
irrelevant from the narrative that you're pushing, right? The narrative that you're pushing should be able to be verified independent of these satellites that you're talking about. Because shut up and listen, right? The space that you're talking about has its own narrative and its own assumptions that need to be verified and have nothing to do with satellites. They exist, according to you, independent of satellites. So you have to verify that. A satellite doesn't verify it. Satellite is just a convenient excuse to uphold the narrative. So remove the satellite, you still have to verify it. The shape of the Earth, you still have to verify that. No, you're just speaking through me like a clown, right? The shape of the Earth, you have to verify that. The fundamental structure of reality, you have to verify that. The gas pressure without containment, you have to verify that. All of these things are independent of the satellite that you say that proves all these things. That's backwards. Remove the satellite and verify each one of them independently, irrespective of any so-called activity that you've done, and then you might have a leg to stand on. If you can express to me in a clear sense that you understood what I said, I may be finished.
Of course, I understood. Of course, I can understand what you said.
Demonstrate your understanding with clarity of speech.
Yeah. So basically, the things you said are that things like gas pressure without a container, space existing, all have to exist without a satellite. That's what you're saying. In other words, they have to be independent of the satellite existing. Well, I've got news for you. That's not how science works. We use tools in science. We use things that measure stuff. That's how we know. That's how we know.
Tell me how science works, Professor.
Okay.
Tell me.
Yeah. That's how we form a hypothesis. We design an experiment. We test that experiment. We draw conclusions.
What'd you observe?
What's the experiment for out of space and rotation of Earth?
Yeah. So basically, one of the ways to do that is to say, well, gee, I wonder what's up there. Maybe I could just send a balloon up there really, really high, and then I get up there and I see, oh, I've got a picture from the balloon, and I notice that this section of what I see is blue, and then above that is black. So I asked myself, well, why the hell is it black? Why is this section of it, this vast section of it above it, black? Why is this thin section blue? So now I need an experiment to test that. So I said, could it be the concentration?
How are you going to manipulate the blue and the black?
Could it be the concentration of gases that makes this area blue and very little concentration of gases that makes the other area black? I wonder if that could be the case. Why don't I design an experiment to test that?
So you manipulated the foundations
that's how science
of our very existence.
I make a tool. I design a tool that
verifies
my hypothesis.
You haven't done an experiment. You've just
that is the experiment.
You've just thought out loud.
Experiment. I formed a hypothesis.
You could have just observed your balloon. You could have observed your balloon expanding as it's increasing in elevation. You could have theorized that there's less, environment around the exterior.
That's not what I wanted to do. It's not what I wanted to do. I decided what I wanted to do when I make an observation.
That's fair.
You need to stop listening to stupid people like Oakley, all right? Think for yourself.
I don't know who Oakley is.
That's not what I wanted to do. If you don't want to do what's necessary, then you're never going to get to truth.
Yeah, no, what I did was I see the photographs in the balloon, and I want to know why this area is blue, why that area is black. Good. How am I going to test that?
Do you actually have the capacity to determine that?
Of course.
Well, you're lying.
How are you going to test it? You saw that this area is blue and that area is black.
You do not have the capacity to manipulate that image or the reality of that image that you're talking about to determine what's the cause for the black or what's the cause for the blue. You don't have that kind of capacity.
Of course I do. You don't.
No, you don't. No, you don't.
Of course I do. Yes, I do.
Yeah, and you're so limited to not even consider that there's an alternative solution. Why you would have different colors.
You might even learn something if you just shut up.
You're not teaching me.
I want to see where he's going.
just
you got a photo.
My hypothesis is that the reason that this area is blue and that other area is black is because the pressure in this area, the concentration of gas particles in this area, is miles greater than the concentration of gas particles in the black area. How can I test that? I wonder how I could do that. You think maybe I could use pressure to do that? You think I could maybe measure it with pressure? That's a great idea. I'll use that. That's my experiment. I'm going to design the pressure. I'm going to test blue versus black, and I'm going to test the pressure of both.
How?
Okay, because my instrument can measure pressure.
How?
So you're just measuring thermal energy.
I'm measuring pressure. Did you not hear the word pressure?
Yeah, which is the energy from the jittering, which is from the thermal energy that the molecules have. Well, that's what's jittering the molecules, the temperature.
No, the molecules.
Press on the plate of your pressure.
Again. What do you?
How the fuck is this ignorant?
What do you think
temperature is defined? I got you. It's defined as the jittering of the molecule.
Right. It's not. Yes, it's just a measure of the energy that the molecules have. It's not an independent thing, like you just said.
It's scalar. No, it's scalar. It's not a vector. Temperature
doesn't matter about that. I said to you, it's a measure. It's a measure of the energy of the particle.
So
of the kinetic energy.
So if there's more collision, if you increase the energy, will increase the temperature, will increase the collisions, your pressure will be increased.
If there's not, I'm talking about the concentration of gases. How many gases there are per cubic meter? How many gas particles there are per cubic meter? The black area has very, very few. We can measure that. The blue area has lots. We can measure that. Okay. Now I can confirm.
That's really easy.
Is confirmed. The blue area is blue because there's more gas particles than the black area. Now, because I know
you'd be able to recreate that. You'd be able to recreate that on ground level, but you haven't.
But your hypothesis, you can have dark particles that you couldn't measure.
Now that I know that the black area is black because there's very few particles, I can now hypothesize.
You don't know that.
That's your presumption, dude.
You
don't know that.
There's also hardly any friction up there because there's hardly any gas particles. Yes, I do.
It's a good assumption. No, you don't. What if there's a high density of dark matter that you can't measure it up there, but it's actually there, but you can't measure it? No. So you assume that it's correct.
It's
nothing? That's not what science says.
No, there's dark matter.
Yeah, there is.
There's matter. Making up shit again.
I'm making up shit. Dark matter, you don't fucking... Walking and fuck that. All right, high five. All right, we agree then. Keep on going. Fine. Wow, that's the first time I heard that shit from a Glober. Oh my god. Thank you.
This guy's just a salty professor, man. Just hurts his feelings that it hurts his feelings that
you just get off and believing dumb things, don't you? You just get off on believing dumb things, right?
He just repeats silly stuff. I suppose that is what your job is, right? Just professing.
It is.
Be true or false. You still get paid, right? You don't care.
I don't tell people things that I know that are false. Okay.
How do you know whether it's false or not?
I test it. I check I know something is not false, or I have confidence in that something is true because I have evidence for it.
So what's your evidence for rotation of Earth?
Oh, plenty of that. Okay. I've got instruments.
I didn't ask you how much evidence you have. I said, what is your evidence?
In both geostationary orbit and in sun-synchronous orbit that proves that the Earth rotates.
I mean, you keep going back to what you get paid for. Why don't you go to the fundamental for evidence of rotation of Earth, independent of your profession? No, independent of your profession, dude.
He said barometric pressure. He said he sent up a barometer, so it measured differential of pressure, thus Earth rotates.
You've got an XY differential, and therefore the whole system that you're standing on is rotating. What are you smoking? What are you smoking? I want some of this, man. That's how I want to spend my Friday evening. Give me some of that.
Stupid or you drinking? Are you stupid or you drinking?
I should start drinking just for you.
I'm mocking you because what you said is ridiculous.
You're not mocking. You're stupid.
No, I'm mocking because you're using a barometric differential between X and Y.
I didn't say anything to do with pressure. Anything to do with the rotation of Earth. You idiot. The rotation of Earth got nothing to do with the barometric pressure.
Insults while stuttering, dude. Just grow up.
What the hell has barometric pressure got to do with the rotation of Earth?
Well, that's what Syrus said. You said.
No, I didn't. That's what your tiny little mind heard. I didn't say that.
So then, what's your evidence?
Rotation of Earth. Hey man, he didn't say that. I strawmanned him right and he just fucking lit up, so I had to. Sorry,
it's a beautiful strawman.
My best evidence that the Earth is rotating are two things. geostationary satellite and sun synchronous satellite. Both of those are both absolutely prove to me the Earth is spinning. Now there's lots of other evidence on the Earth that you can also use. You don't need the satellites to prove it.
I'm asking for first-hand Earth, independent of anything
the satellites are first-hand to me.
No, first-hand for the Earth, primary to the Earth.
For people on the Earth who don't have access to satellites like I do, for the people who don't have access to satellites data like I do, they can use a Foucault's pendulum to prove that the Earth spins.
Oh my days! Okay, have fun with that one, Cyrus. I don't know if I have the time for that. I got to sleep at some point.
Really? What's wrong? Tell me
no,
why that
I'm
doesn't work.
good.
Wait, Noah, you want to have fun with that one?
Yeah, go on. What's wrong with the Foucault's?
Sorry, I just came to the BB Netanyahu AI.
Is this mocking, or are you being more stupid?
Shut
I
up.
just find it funny that you think
Shut up, bro.
a pendulum proves rotation of Earth. That's just hilarious.
The Foucault pendulum definitely does prove the rotation of Earth, 100%.
Dude, I got a pendulum.
Shit. Shut up.
I got a pendulum between my legs. It doesn't prove anything about the ground that I'm standing on.
Is that mocking, or are you just stupid?
The fact that you fail to understand what was said to you is not my problem.
I did understand exactly what he said. I'm also a male.
Anything but actually address the actual question. You're telling me that the car is rolling down the street. I'm like, show me the car rolling down the street. And you're like, look at the tree with the bird on it. Look at the bicycle. Look at the shop with the ice cream. Look at anything but the actual question asked. That's your problem. You assume that you're right, and then you assume that you're right from the get-go, and then meld everything that you see to your point of view.
Absolutely not. I wouldn't have a job as a physicist if I did that.
Yeah, you would. You get.
No, I wouldn't.
Bro, you think your understanding is what pays the bills?
Bro, this guy's divining it with a hanging.
What pays the
He's
bills?
divining with a hanging crystal.
It's your
hanging crystal.
Proves Earth is rotating. With evidence. Evidence.
No, they don't care. They don't care what you understand. They just care whether you toe the line, dude. That's why you get paid. You're not generating this. You're not generating your income from your own creativity. What are you talking about?
If I do generate income from my own creativity.
You're just convenient to the system.
No.
But again, I asked you about the Earth. You know, this thing that we stand on. This thing that we stand on, that trees grow out of, that animals live on, that houses are built on. That thing that you're telling me is moving. Demonstrate primary to that thing. How you could even justify that statement, let alone
that
prove it without a shadow of a doubt.
Yeah, give me a Foucault pendulum. I'll prove it.
No, you got your hanging crystal. Now what?
The only way I'd give you a Foucault pendulum.
Give me a gyro compass, and I'll prove it.
The only way I'd give you a Foucault pendulum is if you remove all assumptions. If you remove all assumptions,
compass, and I'll measure anything at the equator and measure it at each of the latitudes. That proves it.
What's your assumption regarding latitudes? What's your assumption regarding the shape of the Earth? What's your assumptions regarding the shape of the Earth?
That we're way beyond
assumptions. He speaks absolute truth.
The globe.
Yeah, see, he's not assuming shit, right?
If you can't acknowledge the assumptions you're making, then you're literally just what your handle says.
He's got a hotline with God.
Because I've seen it.
You just say stuff.
I've seen it from space.
You just say stuff, man.
You've seen it. You've seen it in space.
I'm 10'5". I've got all the money.
Wait.
I found Jeremy's
Elijah,
lost eye. Like, I can just say anything if I wanted to. It doesn't prove anything.
Yeah, I've seen the Earth from space, so I know it's a globe. That's for certain. I'll show it to you.
You've been up there? You've been up space, or you sent the camera up?
My camera was.
Your camera. Have you ever made a camera?
Camera's cool. Yeah, you can send it. I like model rocketry. I'm into rocketry a little bit.
Yeah.
Yeah, that's fine. That's fair.
How does the camera
took a picture of the Earth while it was there. It's a ball.
Yeah, there's plenty of them.
It's a globe.
No, it looks pretty flat to me.
No,
what were you referencing when you took a picture from space?
Hold on.
Yeah, camera took a picture of the Earth from space.
Yeah, we know. We heard you. When you took your picture from space and you're saying it's a ball, what are you actually referencing to say it's a ball?
Yeah, I can see that it's a ball. Just in the same way that if you looked at something with a telescope, you'd see it's a ball.
I know, but what do you
except when it's a lot closer to you and you get a lot more, it's even much more obvious that it's a ball. You can see the Terminator line. You can see you can absolutely see that it's a ball.
I know. How do you know though it's a ball? Like, what are you referencing in the picture to know that it's a ball?
I'm in my 70s. I know what a ball looks like.
I could show you something. Yeah, but I could show you something.
You can't trust your senses.
A shriveled ball.
I could show you something that's. I could show you something that's flat. One thing that's flat, another thing that's concave, and another thing that's convex. And
I've seen those things.
Yeah.
But show me the Terminator line with respect to those. Put them side on and show me the Terminator line, then I'll tell you which one's the bull.
So the Terminator line is the thing that's telling you it's a.
Yes.
Okay, so the Terminator line is the thing you're referencing.
You see, I get to see what I
like
get to see
freaking out,
where
man.
night and day is on the ball, on the Earth.
Okay, so the Terminator line is the thing you're referencing that tells you it's a ball.
It's one of the things. It's one of the things that I'm referencing.
Okay, well, I mean, that's just where the daytime is and where nighttime.
The other things are the continents.
We can handle the Terminator line before we go on other things. We'll just do one thing at a time, right?
Yeah.
You can only do one thing at a time. So the Terminator line is just where day is and where night is. So I mean, that's not really telling you if it's a ball or not. That's just telling you where the light is or isn't.
Only a stupid person would say that.
Syrus, am I stupid?
You definitely are 100% if you think the Earth is flat.
No. Oh, okay. Yeah.
Try say that to someone if they were standing right in front of you. Even with his one eye, he'd get you right on the jaw. You're just a clown. You're just a clown. You just throw your energy at me.
Don't.
Bro, he just called you an idiot.
Yeah,
don't fall for it. Anybody who thinks the Earth is flat
has
some serious problems with their cognitive ability.
After the patience with which you interacted with him, that's how he responds to you. He's lucky. He's lucky. He's so far away. He's a clown. No one in real life behaves like that without context.
I don't know why do you get off believing nonsense?
He's not a clown. He sent up a barometer. Barometer changed. We got delta barometer. I mean, and then we got Earth ball. I like that. I like where he's at. It's pretty good shit. That's satellite. That's satellite Earth ball. I missed one step. What?
Send up satellite. Satellite takes a picture of the Earth. Earth is a ball. Wow.
Hey, you know what? You may be right. You may be correct. You may be correct. I have not done that. One day, I'm just getting into amateur rocketry. One day, I got you. Maybe. Hey, we'll see. I've seen plenty of photos though. You know, it depends on your lens. Some is ridiculous, and some actually like it's pretty flat. Like with the Felix Baumgartner, the camera from the inside. Yeah. Dude, I like it. Amateur rocketry is pretty cool.
Hey, wait.
One day, if I send up a satellite, cool.
Fundy, you want to play with Professor?
To about 40,000 kilometers if you can. All right.
Fundy, this professor's come to play. You want to play with him?
Funny guy. So you sent yours up 40,000 kilos. Yeah, you got a satellite. I can't do that.
Much more than the rocket that took the picture of Earth went much further than 40,000. It went to
amateur rocketry.
It went to about 400,000 kilometers.
Yeah, that's. I cannot verify that for myself. I don't have the telemetry data for myself. You know what I mean? The onboard computer, I don't have access to that.
When it took the picture of Earth, it was about 48,000 kilometers.
All right, post it. And what kind of lens you got on your cam? Just post it and post the camera specs. That's pretty cool.
Is this alleged hype?
I hope it wasn't NASA, dude. I hope there's actually like your own data, so I could just actually look at it.
It's nothing to do with NASA.
Good. Nice.
All right, I'm heading off. I'll just listen. I have to do other things, so I'll just listen for now. Okay, nice talking to you.
It's to launch more satellites to know.
All right, later, streams.
I mean, that just wasn't professor-like behavior. I don't know.
Since when do you think they behave themselves? You would make for a